Hello everyone! Today I would like to give you a lesson on the topic rectangle and square. Before starting to watch this video, don't forget to subscribe to my channel and like it. I will be very grateful to you for that. You may have visited the Chicago Board of Trade building more than once, and you notice that the main part of the building is a rectangle, which allows for efficient use of space for the stock exchange and offices. So after this lesson, you will know how to find the area of such buildings. And maybe you have also visited the Louvre more than once, and you know that some of the interior halls, in particular the Pavilion Sully and the Quadrangle, have a clear square shape, and this lesson will give you clear knowledge for measuring the areas of its interior halls. A rectangle is a quadrilateral in which all angles are right angles, 90 degrees. Opposite sides are equal and parallel, and diagonals are equal, intersect, and bisect each other. Here are these interesting rectangles in front of you. Let's look at the properties of a rectangle. 1. All four angles of a rectangle are right angles, i.e. equal to 90 degrees. 2. Opposite sides are equal in length and parallel to each other. 3. The diagonals of a rectangle are equal to each other. 4. The diagonals intersect at one point. 5. The point of intersection of the diagonals is equidistant from all vertices of the rectangle. 6. Each diagonal divides the rectangle into two equal right triangles. Formula for calculating the area of a rectangle. S equals A times B, where A and B are the lengths of the adjacent sides. A square is a quadrilateral with all sides equal and all angles right angles, 90 degrees, making it both a rectangle and a rhombus. Here are these interesting squares in front of you. Let's look at the main properties of a square. 1. All sides of a square are equal. 2. All angles of a square are right angles. 3. The diagonals of a square intersect at a right angle and are divided in half by the point of intersection. 4. The diagonals of a square are equal. 5. The diagonals of a square are the bisectors of its angles, therefore they form 45-degree angles with sides. The area of a square is equal to the product of the length of its side times itself. The formula for calculating the area of a square is S equals A times A, or S equals A squared, where A is the length of the side of the square. Here we see that the circle circumscribed around the square is equal to, its radius is equal to A root 2 divided by 2, and the radius of the circle inscribed in the square is equal to A divided by 2. Let's solve the problem root 1. The figure shows a square.
Our task is to determine the unknown quantities according to the given data.
Well, first of all, let's remember that the diagonals of a square are the bisectors of its angles. That is, if any angle of the square is 90 degrees, the bisector divides it in half and will be equal to the angle that I highlighted in blue, 45 degrees. Therefore, if we add an angle of 28 degrees to the unknown angle x, then we get an angle of 45 degrees. We calculate this equation, and we have that the unknown angle is 17 degrees. This is the answer. Let's look at this picture. We see that here too the diagonal of the square will divide it into two equal angles. So our green angle will also be equal to 45 degrees, and the purple angle is also adjacent to this yellow angle. And as we remember, the sum of adjacent angles will always be equal to 180 degrees. So 180 minus 75 equals 105 degrees. And then we must remember the basic rule that the sum of the angles of a triangle is always 180 degrees. So we compose this equation, substitute unknown quantities and known quantities. So we solve this equation and find that the unknown angle is equal to 60 degrees. Therefore, the answer, 60 degrees. Problem root 2, we see that we have a circle circumscribed around a square.
Determine the radius of the circle using the given data.
Well, first of all, I will draw a square separately and I will transfer the radius of the circumscribed circle here. From this rearrangement, the length of the radius will not change. So we have this yellow right angle triangle. And what do you think? Why did I transfer this radius here? And because by the tangent of the acute angle, we can find the length of our radius. Tangent of b equals r over 13. And from here, to find r, we need 13 times tangent of b. This will be our answer. Let's consider the following problem. We are given a square ABCD. The angle ABCL equals gamma, and CL equals 16. We are asked to find the radius of the circle inscribed in the square. Now, let's recall that the radius of a circle inscribed in the square is equal to half of its side. The side of the square will be equal to the diameter of the circle. Therefore, I mark 2r in red here. Also, if we remember what alternate interior angles are with two parallel lines, we have that BC and AD are parallel, and CL is a secant. Therefore, angle BCL equals angle CLD equals gamma. We take this yellow right triangle and recall the definition of the sine of an acute angle, and we have that sine of gamma will be equal to 2r over 16.
We can simplify this expression by 2.
And we get that sine of gamma is equal to r over 8. Hence, r equals 8 sine of gamma.
So, if you understood everything today, I would give you Harley-Davidson's CVO Road Glide RR as a gift. If you are worried or excited because you didn't understand something, no problem. Watch this video again slowly. Never give up, and I wish you to understand it as soon as possible. Bye.